When you plug in your phone or start up a game console, power feels instantaneous. It is so reliable that we rarely think about where all that energy actually begins. We often treat electricity like a natural resource we find in the ground, but it functions more like a manufactured product. Because it cannot be mined or pumped, we have to create it by converting other forms of energy into a flow of power we can move across wires. The wall socket in your home represents the final delivery point of a manufacturing process that spans hundreds of miles and never stops. To manufacture that power, we use a generator. Inside, a giant magnet spins within a coil of copper wire. This motion pulls on the tiny electrons inside the metal, pumping them through the wire to create an electrical current. But that magnet needs a constant physical force to keep it moving. It is attached to a massive wheel with angled blades called a turbine. To make electricity, we just need to find a way to push those blades and keep the wheel spinning. This one mechanical task drives the entire global energy industry. Whether we use coal, gas, or the wind, we are ultimately looking for the most efficient way to spin that giant wheel. For over a century, our primary tool for spinning the wheel has been fire. Power plants burn coal, oil, or natural gas to boil water. As that water heats up, it turns into high-pressure steam. This pressurized steam is funneled through a pipe and blasted against the turbine blades. It acts like a high-speed jet of air, forcing the wheel to spin at thousands of revolutions every minute. These boilers currently produce about 58. While boiling water with fire is a reliable way to generate power, its impact on the environment makes it a difficult technology to rely on for the future. We can also create that heat without burning anything. In a nuclear reactor, we split heavy uranium atoms apart. This process, called fission, releases an intense burst of energy that makes the reactor incredibly hot. This fuel is remarkably efficient. A single uranium pellet the size of a pencil eraser holds as much energy as a full ton of coal. We use that heat to boil water and spin the turbine, just like a traditional plant, but with zero carbon emissions. The challenge is that once the fuel is used, it remains radioactive for thousands of years, meaning we must store it in secure facilities. Nuclear energy acts as a carbon-free powerhouse, but it requires us to manage its waste long after the electricity has been generated. We can also let nature spin the wheel directly. Hydroelectric dams use the weight of falling water to push the turbine, and wind turbines use the energy of the breeze to turn the blades without needing to boil any water at all. We can even tap into the Earth's internal heat. At a geothermal plant, like the one seen here, the Earth provides the steam for us. By drilling into hot underground reservoirs, we can pipe that natural pressure straight to the surface to spin the turbine. These sources are clean and free, but they are also intermittent. We can't control the wind or the water in the river, which makes it harder to predict exactly how much power we'll have. Then there is the solar panel. This technology is unique because it skips the turbine and generator entirely. When sunlight hits the panel, it knocks electrons loose and sends them straight into the wire. Using nature to power our lives provides us with clean energy, but it requires us to work around weather patterns we cannot change. Everything we've discussed connects to the grid, a live network that must stay in a state of perfect balance. This chart shows how our demand for power changes throughout the day, and the stacked blocks show how our power plants must rise and fall to match it. When the sun sets or the wind dies down, those blocks shrink. To keep the lights on, we need baseload sources, like nuclear or geothermal, to expand and fill that gap. Maintaining a modern society requires a team of different power sources, each using its specific strengths to ensure the grid never goes out of balance. We are currently in the middle of a massive shift in how we power our world, moving away from old boilers toward a combination of splitting atoms and capturing natural forces. The next time you flip a switch, you are physically connecting your home to a spinning wheel or a beam of sunlight hundreds of miles away. Electricity is a mechanical triumph, and we are now redesigning that machine to ensure it can power our future while keeping our planet healthy.